Hello guys, welcome in today's session. I am Professor Fayyaz Khawani from Department of Mechanical Engineering. In today's session, we are going to discuss what is epicyclic gear train and how to find out the different speed of the elements in the epicyclic gear train from the unit number 3 gear train from theory of machine subject. So guys, in front of you the simple gear train is shown here, in which there are 4 elements. One is fixed body, second one is gear A, third is gear B, and fourth element of gear train is arm C. Okay, now gear A is pivoted at point O1. Gear A is pivoted at point O1 on the fixed body, which is free to rotate. One end of the arm C is also pivoted on the same point O1. Another gear B meshes with gear A and its axis on the other end of the arm C at point O2, about which gear B can rotate. If the arm is fixed, if this arm is fixed, the gear arrangement is act as a simple gear train, in which when you rotate gear A in clockwise direction, the gear B will rotate in anti-clockwise direction or vice versa. But if the gear A is fixed on the fixed arm and the motion is restricted and the rotation is restricted and the arm C is rotated about the axis of gear A, arm C is rotated about the axis of gear A, then the gear B will rotate upon and around gear A. Understand clearly? When the gear A is fixed and the motion is restricted and the arm C is free to rotate and it is rotated in anti-clockwise direction or clockwise direction, at the same time the gear B will rotate upon its own axis and around gear A. Such a motion is called epicyclic motion. So the gear train arrangement in such a manner that one or more of their members rotate upon and around another member is called as epicyclic gear train. So epi means upon and cyclic means around. That's why this simple gear train is called as epicyclic gear train. I repeat again, when one element of the system is fixed and it is not rotated, at the other side the arm C will rotate, at the same time B will rotate upon the axis O2, at the same time it will rotate around axis O1. So this construction of gear train is called as epicyclic gear train. On the other hand, the gear A rotates about its own axis gear A is rotated about its own axis. That's why it is called as sun gear. At the same time, the gear B rotates around gear A, so it is called as planet gear. So this arrangement is called as sun and planetary gear train also. So epicyclic gear train is also known as sun and planetary gear train. These are some examples of applications of epicyclic gear train. Epicyclic gear train are used for transmitting high velocity ratios with gears of moderate size in lesser space. This epicyclic gear train is used in back gear of lathe. You can see here image. Differential gear of automobile. This is the application. Differential is the application of epicyclic gear train in automobile. Next, hoist pulley block. In hoist pulley block, the epicyclic gear train is used, and in wrist ratchets you can observe here the epicyclic gear train is used. These are some different construction of epicyclic gear train or sun or planetary gear train. In first image, the innermost part is act as a sun gear, and 3 planet gears are used in this application, in this construction, and the outer ring is there. In second image, 1 sun gear is there and 2 planetary gears are rotated in the annulus or outer ring. In fourth image, 1 sun and 1 planet arrangement is there, which is rotated in outer ring, and this is the differential of automobile, in which you can see the bevel gear and sun and planet epicyclic gear train. Now, in this sun and planetary gear train or epicyclic gear train, if gear A will rotate in anti-clockwise direction, gear B will rotate in clockwise direction. At that time, arm C is fixed. If A is fixed, arm C and gear B will rotate upon and around gear A. Okay. Now, if gear B is fixed, gear A with the fixed body and the arm C will rotate upon and around gear B. So if one element is fixed, other two is rotating. That's why the speed ratio you can't find out by as per our previous gear ratio formula, which we will learn in gear train, simple gear train. N1 upon N2 is equal to T2 upon T1. By this formula, you can't find out the speed ratio of the air in simple gear train. So for this, we have to first understand the sign conventions which is used to find out the velocity ratio of element in gear train. Now see here, sign convention and what is external and internal pair. Before solving the numericals or before finding out the speed ratio of the elements in simple gear train, in epicyclic gear train, we are assuming the anti-clockwise rotation as positive sign and clockwise rotation as negative sign. We are using positive sign for anti-clockwise rotation and we are using negative sign for clockwise rotation. And what is external and internal pair? As I am showing here, these two gears, pair is forming the external pair, And in the external pair, when one gear is rotating clockwise, another gear will rotate anti-clockwise or vice versa. In other words, we can say that in external gear pair, both the gears will rotate in opposite direction. But in case of internal pair, see, in that outer ring, the gear teeth are cut from inner side of that ring. So these form an internal gear pair. And in case of internal gear pair, when one gear will rotate in anti-clockwise direction, the outer ring will also rotate with the same direction as that of first gear. In other words, we can say that in internal gear pair, both the gears will move in same direction. Okay, so in external gear pair, one gear is making positive revolution, other gear is making negative revolution. But in case of internal gear pair, both the gears are making same direction. Both the sames are using same sign convention. In this figure, we can see here this gear is rotating anti-clockwise direction. So outer wing is also rotating anti-clockwise direction. So both the gears have anti-clockwise rotation, so both the gears have positive sign. This we have to understand clearly for solving the numericals. So these numericals are solved by a tabular method. In front of you, a table is written here. In vertical column, the condition of motion is written here. Why? Because if one gear is fixed, another is rotating. If one element is fixed, another two is rotating. That's why it is very difficult to find the velocity ratio as per the simple gear train. So this tabular method is used to find out the velocity ratio. In vertical column, I am writing conditions of motion of the elements, and in horizontal rows, I am writing all the elements in epicyclic gear train. What are elements are present there? Gear A, if one sun gear is there and two planetary are there, one sun, three planets are there, and arm is there. These all elements I will write in a row. Okay, so in simple gear train, the simple epicyclic gear train as shown in figure, there is arm C is there, gear A is there, and gear B is there. Fixed body is also there, but it is stationary, so that is not considered in this table. So first condition is that I am putting arm fixed. Arm is stationary, arm is fixed. Gear A rotate through one revolution. Gear A, I am giving the motion, a rotation to gear A, one revolution, that is one revolution anti-clockwise direction. When arm is fixed, so velocity of arm A, speed of arm A is 0, and I am giving one revolution anti-clockwise direction to gear A, so speed of gear A is plus 1. One revolution in anti-clockwise direction, and my convention is anti-clockwise direction is plus sign. So the speed of gear B in this condition, in this situation, when arm is fixed and one rotation is given in anti-clockwise direction to gear A, at that time the speed of gear B is minus TA upon TB. How? I simplify this term by solving this velocity ratio formula. Velocity ratio is equal to NA upon NB is equal to minus TB upon TA, as A and B will form external pair. So one gear will rotate, if A gear is rotate anti-clockwise direction plus sign, so B gear will rotate clockwise direction. So clockwise rotation will be minus sign. Okay, the speed of driver to the speed of driven is equal to number of teeth on driven wheel divided by teeth on driver wheel. This is our standard formula to find out the velocity ratio. So the same formula I will write here. NB upon NA is equal to minus TA upon TB. I am taking the reciprocal of this term and on this term from both the side. NB upon, why I am taking this in numerator NB? Because I have to find out speed of NB. Speed of NB. So NB upon NA is equal to minus TA upon TB. So what is the value of NA? NA, this is plus 1. Plus 1. One revolution I am giving to gear A in anti-clockwise direction. So speed of NA is equal to plus 1. The same value I am putting here, NA is equal to plus 1. So NA is equal to plus 1. So value of NB I am getting here, NB is equal to minus TA upon TB. The same value of NB I am putting in this table, minus TA upon TB. Now the second state in this table is arm is fixed and give X revolution to gear A. Give X revolution, gear A rotates through plus X revolution means anti-clockwise direction. Gear A is rotating through X revolution. So if arm is fixed, this will become again 0. X revolution to gear A. So I am multiplying this by X plus X I am getting here, and gear B, the value of the speed of gear B is equal to minus X into TA by TB. Just I am multiplying here by X to this term. X rotation is given to gear A. That's why I am multiplying X to all these terms. Now the third condition, add plus Y revolution to all the elements individually. So speed of C is plus Y, speed of gear A plus Y, and speed of gear B plus Y. Now the last step in this table is total motion. Fourth step is total motion, and this total motion is addition of step 2 and step 3. So 0 plus Y is plus Y, plus X plus Y, addition of these two, and addition of these two is Y minus X TA by TB. So remember this, if you have to find out speed of B, if your first term is wrong, this will directly affect this last term and your answer will be wrong. So while writing this term, be careful, because this directly reflect in this term and your answer will be wrong. If this will wrong, this will wrong, and if this second step will be wrong, this final step will be wrong and your answer will be wrong. So while writing speed of gear B, take precaution, and you have to directly calculate the speed B here by this formula. Now the same thing is written in this slide, so I am not discussing again here how that table is formed. Now I am understand this table by solving these simple numericals. The problem statement is given here. In an epicyclic gear train, an arm carries two gears A and B. I am showing figure here. The arm carries gear A and gear B having 36 and 45 teeth respectively. The gear A is 36 teeth and gear B is having 45 teeth. If the arm rotate at 150 RPM, arm C rotate with 150 RPM in anti-clockwise direction, anti-clockwise direction about the center of gear A, which is fixed. Determine the speed of gear B. Determine the speed of gear B if the gear A, instead of being fixed, makes 300 revolutions per minute in clockwise direction. What will be the speed of gear B? Okay, this is condition which is given in problem statement. Now come to the solution. TA is given 36, TB is 45, and speed of arm C is given 150 rpm and it is rotating anti-clockwise direction. So NC is equal to plus 150 rpm. Gear train is showing in figure. So I'm writing the same table here, in which condition of motion is written in vertical column and the different elements of gear train is written in horizontal row. Arm C, gear A and gear B. First condition in the table is fix the arm and give one rotation and in anti-clockwise direction to gear A. Okay, so a rotation of C is 0 as arm is fixed, and one rotation in anti-clockwise direction given to gear A. So speed of gear A is plus 1. Now what is the speed of gear B? So as we discuss here, speed of gear B in simple element is simple gear train is NA divided by NB is equal to minus TB by TA. So the same procedure I am using here to find out speed of NB. NB is equal to, I am getting here minus TA upon TB. The same value is putting here minus TA upon TB. As A and B form external pair. So if gear A is rotating in anti-clockwise direction, gear B is rotating in clockwise direction, and for clockwise direction, the sign indicate, as per our assumption, this will rotate in clockwise direction. So minus sign will come to that ratio TA by TB, minus TA by TB. Second step, arm is fixed. Gear A rotates through plus x revolution, so it will become 0 plus x minus x TA by TB. Multiply x to all these elements. Second step. Third step, add y revolutions to all the elements. So plus y, and for gear B also it is plus y. And the final step in this table is addition of row 2 and row 3. 0 plus y is plus y, here x plus y, and third and last one is this addition is y minus x TA by t. Now as per condition, now in problem statement we have to find out, determine the speed of gear B. Determine the speed of gear B for this given condition. So what is the speed of gear B? Speed of gear B in last row is y minus x TA by t. If this formula will wrong, your answer will be wrong, and this will come wrong due to this term. So while finding this term, you have to take precaution. Okay. Now speed of gear B is equal to y minus x TA by TB, and speed of arm is given 150 rpm. Speed of arm we are getting here plus y. So value of plus y is equal to 150 rpm. So y is equal to 150 rpm. Okay. Now come to the solution. The speed of arm is 150 rpm anti-clockwise. Therefore, from the fourth row of the table, y is equal to 150. Also, the gear A is fixed. That is given in the condition. Gear A is fixed. See, about the center of gear A, which is fixed. Gear A is fixed. That means NA is 0. NA, speed of A is 0. So x plus y is equal to 0. Y is equal to 150. X plus y is equal to 0. And we have to find out y minus x into TA by T is how much. So speed of gear B, the formula for speed of gear B is equal to y minus x TA by TB. I am taking from this last block. Speed of gear B, y minus x TA by TB. So value of y is 150 minus, what is, x plus y is equal to 0, but y is equal to 150. So value of x is equal to minus 150. Value of x is equal to minus 150 rpm. Putting that value of x minus 150, this minus and minus will become plus here. So plus 150 into value of TA and TB I am putting here. So after solving this numerical, speed of NB is getting here plus 270 rpm. That means gear B will rotate by 270 rpm in anti-clockwise direction, as plus sign is indicating anti-clockwise direction. So in the examination, while writing the solution, don't write only 270 rpm, but write 270 rpm in anti-clockwise direction. If you won't write the direction of gear, you will lose 1 mark. That's why you have to write down the direction also along with the RPM. Okay. Now the second question is asked here. If the gear A, instead of being fixed, makes 300 RPM in clockwise direction, that means NA is equal to minus 300. NA, speed of A, instead of being fixed, it makes 300 rpm in clockwise direction. So clockwise direction is minus sign. So speed of NA is equal to minus 300 rpm. At that time, what will be speed of P? Now from the last table, y is equal to minus x TA by TB is equal to how much? Now here, instead of arm fix, gear A is making 300 revolution. So x plus y is equal to minus 300 and y is equal to 150 as per given here. Y is equal to 150 rpm, speed of arm. So putting the values of all the terms here, x plus y is equal to minus 300. So x is equal to minus 300 minus 150. Value of y is equal to 150. So this 150 will become here minus 150. So y is equal to minus 450 rpm. Putting the values of y in this equation, y is equal to x 450, or here become value of x 450. So value of y is equal to 150, minus minus will become plus here, plus 450 into TA by TB, 36 divided 45, it will become 510 rpm, as plus sign is there. So 510 rpm in anti-clockwise direction. This is our solution. Okay. So at the end of this session, the student can understood what is epicyclic gear train, and the student can solve the numericals on epicyclic gear train. Thank you so much.